picking up where we left off last time, here's an example of something that's similar to the homework as well. We're going to find sine theta, cosine theta, and tangent theta using the Pythagorean identities, given a little information, all right? So here's the first problem, example 2. Suppose theta is greater than pi, but less than 3 pi over 2. Okay, so where does that put theta? Well, it's greater than pi, but less than 3 pi over 2, so I claim that it puts theta, the terminal side, in quadrant 3. Now, in quadrant 3, the cosine is negative. Well, that makes sense because I give you cosine is minus a third, but also the sine is negative in quadrant 3. Yes? In fact, let me draw a little picture over here. Greater than pi, here's my angle theta, it's over here somewhere. Okay, sine, the x and the y value are both negative there, all right? So if cosine theta is minus 1/3, then I have the Pythagorean identity, sine squared plus cosine squared is 1. So sine squared theta add cosine squared theta, which is minus 1/3 squared, equals 1. Minus 1/3 squared is 9. I pull it over the other side. Sine squared theta is 1 minus a ninth. Finding a common denominator, I get 8/9. Sine of theta then algebraically is plus or minus the square root of this, which is plus or minus square root of 8 over the square root of 9, or plus or minus 2 root 2 over 3. Now, algebraically, sine is plus or minus, but I argued I was in quadrant 3, so in fact, the sine of theta is what? Minus 2 root 2 over 3. Made another correction. All right. So that's the sine. What's the tangent? Well, the tangent is what? Sine over cosine, but the sine was minus root 2 over 2 divided by 3. The cosine is minus a third. And so I get minus 2 root 2 over 3 times minus 3 over 1. And what's my final answer? 2 square roots of 2. All right, so there it is worked. If I am in quadrant 3, then both sine and cosine are negative. All right, let's look at another example. Same kind of story. Find sine theta, cosine theta, and tangent. Now I tell you that what? Secant is minus 13/5 and tangent is negative. All right, so what's secant? 1 over cosine. So if secant is minus 13/5, cosine is its flip, minus 5/13. Now, if cosine is negative and the tangent is negative, then since tangent is sine over cosine, that tells me sine has to be positive. All right, so I'm thinking about that early on. Sine's positive. All right, now I use the same Pythagorean identity. Sine squared plus cosine squared is 1. For cosine squared, I'd stick in minus 5/13 squared. Then I saw for sine squared is 1 minus this squared, which is what? 25 over 169. I find a common denominator. I get 144 over 169. Isn't that nice? 2 perfect squares. So what's the sign? Well, algebraically, it's plus or minus the square root of 144 over 169, or plus or minus 12 over 13. But I've just argued that since tangent is negative and cosine is negative, sine has to be what? Positive. Therefore, sine is 12/13. What's tangent? Tangent is sine over cosine. Sine was 12 divided by 13. Cosine way up here was minus 5 over 13. And when I clean things up, I get a tangent of minus 12/5, which makes sense. Tangent should be negative. All right, so there are a couple of examples of how you can use the Pythagorean identities, right, to find other trig values if I give you enough information. Finally, in the homework, I ask you to simplify the following terms. What I really want you to do is put things in terms of sine and cosine, cancel out anything you can. One of the homework problems I'm going to do right here, cosine theta times sine theta times the quantity cosecant theta plus secant theta. I want you to simplify that. All right, now where is that in chapter 3? The answer is, it's right here. It's number F. So I'm going to do part of your homework. All right, so what do you do? Well, cosine theta, sine theta times 1 over sine theta. Well, sine theta is canceled. I get cosine theta. And then this times this, cosine cancels. I get sine theta. What's my answer? Sine theta plus cosine theta. That's as simple as it gets. Example 5. Well, example 5 is also in the homework. What a guy. In fact, it can be found over here, letter K. All right, so let's see how we would do that. Sine squared theta minus 2 sine theta add 1 over sine theta minus 1. So what I can think about is, if I think of sine theta as my variable, this is like x squared minus 2x plus 1. That, my friend, is a perfect square. And that's all I'm trying to do with this homework, is realize that sine theta is just a fancy variable. So in fact, sine squared minus 2 sine add 1 is just what? Sine theta minus 1 all squared. You can factor it. It's a quadratic-like equation is what they call it. So now I have sine theta minus 1 all squared divided by sine theta minus 1. Guess what? One of those cancel to give me sine theta minus 1, and that's as simple as that gets. Now a little warning. Yes, there might be several different ways you can simplify things because I'm not specific. I don't say write everything in terms of something. I just want you to do a little algebra on it. All right, that's essentially all I have to say with respect to chapter 3. Have fun, work hard, and bye.